A pleasant day, everyone. I am here again, your teacher Jem, and I'm going here to teach you on how to solve in the mathematics. So now, our last topic is about how to identify conic sections. So now let's moving forward. Uh, we're going to tackle about the limits. But before that, I'm going here to share with you what limits. So limits suggest a boundary that may be reached or not, or possibly exceeded. Lim a sub n is equal to n. The limit of a sub n is equal to n as increase without bound is f. So we have here the basic limits. Number one, lim 1 is over n is equal to 0, which is our n is infinity. And the second, lim n is equal to infinity, which our n is infinity. We're going to assume that our value of n is infinity. So here we have here an example. Our example number one is lim quantity of n plus 6, which is the value of our n, is equal to infinity. So we're going to solve that, and I'm going here to solve like this. Lim lim and lim a subset of n plus lim 6, which is n is equal to infinity, and n is equal to infinity. So to solve that, we're going to substitute the value of n, which is infinity plus 6 is equal to infinity. So always remember that all constant number is equal to infinity. So we're going to move to number 2. Number 2, which is ln 4n plus 1 over n. N is infinity again, is equal to ln the quantity of 4n over n plus 1 over n. So now we're going here to ln the quantity of 4. Why 4? We're going here to cancel out here para mabilin ang 4. So we have 4 plus 1 over n. So we're going to substitute the value is equal to 4. We're going to separate this. We have ln 4 plus ln 1 over n is equal to infinity, and n is equal to infinity. So we're going to substitute 4 plus, because we have here 4. So here, when you remember the basic limits we talked about earlier, and 1 over n is automatically is equal to 0. So we have here, so n is equal to 4. So that's how to get our limit.